Hello, welcome back to lecture 2. Hopefully the audio is a little bit better. I now have this ridiculous microphone set up so we can see. The problem was last time I was recording using my computer's mic, but this computer is hooked up to my iPad, the external camera, the webcam is on, and it was so hot, the fan was running so high that the fan was essentially being picked up by the microphone, and it sounded like I was in a wind tunnel. So apologies for that. Hopefully this is a little bit better. All right, here we go. So a couple goals for today. We're going to go over the homework system. We're going to talk a little bit about success strategies in this course, and then we're going to review a little bit of the math that will be useful for us to succeed in Physics 1. And the related readings for this lecture is going to be Chapter 1. So let us start first with the homework system. So let me bring this up. I can make this a little bigger, take up the screen. So again, the homework system is going to be done completely online through the software ExpertTA. The link to the actual homework site is available at the top of our Moodle page, but you have to register for our class first before you can start doing the homework. So there's a link both in the syllabus and down here in course materials. This link here should take you to a page where you can sign up for the homework. Actually, we can just go to it right now so we can see what it looks like. Yeah, this should be right. The registration information, just make sure it shows up as this class taught by me. If this does not pop up and it's asking for some sort of class code, the class code is this long string of letters and numbers at the end of the link, which is also in the syllabus if you need it. And I think you have to type it exactly as is. I think it can be sensitive as to dashes or not, so try it with or without dashes. If this link doesn't work, if nothing seems to be working, reach out. Technology sometimes thwarts us in that way. All right, but once you do that, let's actually go into the system. You'll be brought to this ExpertTA site where you will log in with your St. Mary's email. For some reason, I did not follow my own advice and used a different email. And once you log in, there we go. You should be taken to this home page for our class. Again, it should show up here at the bottom as being Physics 1 taught by me. And here is where you'll get access to all the different homework assignments that are available to you. Quizzes might also be done on ExpertTA. Review packets will also be done through ExpertTA, and this is where you'll access all of them. There is a tutorial that can kind of walk you through ExpertTA. So while this is not graded or weighted in any way, I highly recommend you take it. I think it only takes students like 10 minutes or so. And it will become very important because it also teaches you how to enter mathematics using ExpertTA and also helps you with drawing free body diagrams, which will be important once we get to Newton's laws. Let's see, so things that you might need to access, and I think the tutorial goes over this. In the class menu, this drop-down menu, you won't see all of these because some of these are instructor specific, but you should be able to see your grades, the grades that are associated with the homework assignments. And again, we need to make sure that those grades on ExpertTA get properly translated over to Moodle. And then there will be kind of problem solutions. You can access the solution sets to the homework sets once they are past their due date, and a practice area where you can practice on various problems as well. So the way you do this, I guess, once this populates, you can see that each assignment has a little tab, which kind of can give you a sense of how long the problem set is. In this case, it looks like it's 5 problems. Looks like you can even kind of get previews of what they look like if you hover your mouse over it. Then the first homework assignment looks like I have it at 10 problems. Again, some of this might not be visible to you. Depends on, some of this might be instructor specific, like you probably don't see publish. That's just when I make it visible to you. But you will see some sort of start date, the earliest date you can start to actually do the homework and submit it to me. The due date, so if you want to get up to a possible 100% on the homework, it must be submitted before this time. And then you can still submit the homework late, but remember that every day it's late, an extra 10 or 20% is taken off. I forget what I said in the syllabus. And then if you are more than 5 days late, then no credit is possible. So the due dates for the homework, it's always I will assign it on a Monday and then it will be due the following Monday. And the content of the homework will try to follow the discussion section schedule. So this first homework actually is essentially just on this lecture, because we'll only have time to talk about this lecture in our synchronous meetings on Wednesday and Friday. So the idea is that the homeworks, you will have had time to talk about the material in a synchronous discussion section before I ask you to do something that is submitted for a grade. All right, so let's actually go through an example and see kind of what this looks like. So if you click on the assignment that you want to do, a little drop-down menu should appear. Again, not all of this will appear for you, but in whatever appears for you, there should be a take assignment. So by clicking that, you're taken to some sort of honor code that you should agree to. And then you are taken to this main page, which will show you kind of how the homework is accessed and done. So the main problem is shown kind of in the main bulk of the screen. Your assignment status and the problems are here on the left. So you do not have to do the problems in order. So it looks like this one, you have to watch this video, and then after you scroll down here, you're going to answer some question about the video, it looks like. So why did it start at problem 5? That's interesting. Well, this goes to show what I was about to say, is that you do not have to do the problems in order. You can use these links on the side and jump around and do problems out of order if you want to. And I think this gives you, a sense of which problems you have completely completed. Maybe there are some that you've skipped, maybe some you've attempted but have not completed yet. So you can get a sense of kind of where you're going for all the problems in the homework set. So let's look at number 2. Yeah, so the idea here is that the top will give you some sort of description. A can contains 395 milliliters of soda. And then there it shows you some random variables. So the idea, why is this a different color? It's a different color because every student gets a different number. There are randomized variables and symbols and numbers. So not everyone gets a unique homework assignment. It's the same kinds of problems, but you all have unique numbers. So the question is, a problem contains this much soda. How much is left after 318 milliliters is removed? And so the tutorial, again, will walk you through how you enter this stuff. But you can, if you had a calculator and you need to figure this out, you would type in your answer here. And then once you are done, click Submit. And in the cases where you have to enter equations or symbols, there will be relevant symbols and functions available for you to type in if you need to. And then there's hints, feedback, and I give up, which I'll go over in a little bit. So this is for the tutorial. So actually, we can actually just show you that this actually, it can be kind of smart. I can enter mathematics and it will contribute. As how much is left after this much is removed, it's just the difference of the two. If I'm confident that's, yes, I'm confident this is correct, I submit. It says, aha, correct. You can continue to the next part, where you can close and look at some of the details regarding this particular problem. You'll be able to see all your previous attempts. You'll be able to see the grade that you got on it, the correct answer, and then you'll eventually be able to go back to this and view a solution set once the homework problem set is due. And then notice here it says completed on the left-hand side. So we look at this. Now it says this problem is completely done. I've gotten part A correct. So I can jump to a different problem and do something else. So another thing to show is that here on the right, which is not super meaningful for this assignment because this is just a tutorial, this shows you, you're allowed to make multiple attempts on a problem. Actually, let me just not do it in the tutorial section. So let me go back to the home page. Now let me go into homework 1. So take assignment, agree and continue. So here's the first problem. A circle is the diameter of blah. What is the area of the circle in centimeters squared? All right, so if you look here on the right, it shows you currently you have 0 deductions on this problem because you have not made any attempts yet. So you could potentially get up to 100% on this problem. You have 10 submissions remaining, so you can make up to 10 more attempts on this problem. The only cost is that each attempt you make that is incorrect, there's a little bit of a cost to that. You can't just wildly, try to guess the right answer. Every incorrect answer you get, I take off 2%. which again means if you use all 10 attempts, and you finally get the answer right on the 10th attempt, you get an 80% then on that problem. And this, for the first homework, I made it a little bit more lax. For future homework assignments, I don't think I'm going to do 10 and 2. It's going to be more like probably something like 7 and 3 or something like that. Just to encourage you to make sure you're really thinking about the problem before you click the submit button. But if you do get the problem wrong, what I really like about ExpertTA is that it can be helpful in terms of providing you feedback and hints. So, for example, let's suppose let's do this problem incorrectly first and see what happens. So what is the area of the circle in centimeters squared? I might remember in geometry there's this pi r squared is the area of a circle, but maybe I confused radius and diameter. So maybe I'm going to do this incorrectly and do pi times the diameter squared, which is incorrect. So let's see. I need a calculator, I guess. If you have a physical calculator, that's great. For this class, you don't really need a super fancy calculator. Any scientific calculator that will do. It doesn't even necessarily have to be a graphing calculator. Past students have really liked using, let's see if I can guess it. Yes, Desmos. It's essentially a free graphing calculator software that you can access online, which I don't use myself. So let's see here. Yeah. So I guess under math tools, graphing calculator, scientific calculator. So let's go with the scientific calculator. All right. So again, I wanted to do, this problem was a diameter of blah. Let me copy that. And then what is the area in centimeters squared? So the units are fine, but I'm going to incorrectly do this as pi. Oh, that's nice. I can just type pi, or I can use a little symbol here, pi times, and I'm going to do the diameter squared. Yeah, that's actually just kind of nice. All right, so you do that pi diameter squared, it gives you this answer. Let me copy and paste that. So I'm going to submit that as my answer. Oh, it looks like it doesn't let you copy and paste. It's probably for the best. 551. Yeah. I guess it'd be 552. In terms of sig figs or significant units or significant digits, I personally will not worry too much about them in this class, so just always include 1 or 2 decimal spots in your answer. For ExpertTA, I don't think it also worries that much about significant units, so again, just 1 or 2 decimal spots. I would say be on the safe side, maybe include 2 or 3 decimal spots, and ExpertTA will be fine with that. All right, so suppose I think this is my answer. I click submit. Incorrect answer. Specific feedback is available. There might also be hints. Okay. So notice that next to submit was also hint, and now that I've submitted at least one incorrect answer, the feedback button has appeared. I think and then if you just completely give up, you give up, but then obviously if you give up, you lose every possible point and you get 0%. I think feedback should be encouraged, so I don't have it set to take off anything for feedback. So feedback will always be free. So let's see what it says. You may have confused the radius and diameter of the circle. Which I did. And then notice that sometimes the problems will have hints. Different problems have different amounts of hints, but to access a hint, there will be a slight deduction on what you get. All right, so confuse radius and diameter. All right, so let me go back. Let's see, I'm not going to do diameter, but I'm going to do radius, which is half. And I was adjusted my answer to 8.387. 8.387. Is that correct? 7, 9. All right, so I guess 7, 8. All right, now I'm going to do that. Correct answer. Continue to the next part. So in this case, I got a grade of a 98% on this particular problem. And it shows my previous attempts that I've tried before. All right. Anything else I need to show? Again, you can do things out of order. You can also leave and come back. You don't have to start and complete everything in one sitting. I could go to class management where I've now left the homework assignment. I could leave ExpertTA entirely. I could go do something else. I come back, I click take assignment, I have to re-acknowledge the honor code, and notice that my status is maintained. So I can come back, and I would recommend this actually. Don't wait until the last minute for sure, and don't try to do everything at once. You can work on, usually I'll have about 10 problems or so. So doing, a couple problems a day could be a good strategy so you don't get overwhelmed with these problems. Usually Sunday night. All right. And I think that's it. So I would recommend everyone doing the Intro to ExpertTA. Again, that is not graded at all. And then your first homework assignment is available and it's technically will be available. I've already made it available, but it is not due until it looks like August 31st at 8 a.m. Which again will mostly be on today's lecture, since this will be the only lecture we can talk about in class before it's due. Alrighty, log out. Alright, so reach out if you have questions regarding the homework system. And again, if you are waiting to buy an access code through, say, the bookstore, you are allowed to do a 2-week trial period with ExpertTA before you commit. So everyone should do the trial period. And then once the trial period is over, you can then provide a credit card, or hopefully by that point, the bookstore has given you your access code that you've purchased. You can still, all the stuff you do on the trial period will still be recorded and logged. So you will not lose any information, as long as, of course, you're signed up for my class. All right. Let us talk a little bit about how to succeed in physics. Physics, unfortunately, has a little bit of a notorious history with being very challenging and difficult. And it doesn't have to be. The reason that it gets that sort of mentality, I think, is because physics is a class that expects you to take in a lot of new material, process it, and then do something novel and unique with that information. It is not a class where you can succeed just by memorizing and regurgitating on an exam. That does not work in physics. And sometimes I really do believe if you have never taken physics in high school, I honestly think you're kind of at an advantage compared to those who have, because unfortunately, not to put down your high school teachers, but sometimes high school teachers teach physics in a way where it favors just memorize all the things and then word vomit them all onto an exam, and you will succeed and get an A. And unfortunately, in college physics, that definitely will not work, and it will not work in my class. The idea with physics is that we are expecting you to learn material, so there will be content, there will be things that are worth memorizing, but you're learning strategies, techniques, tools that allows you to then solve novel problems that I then give you on, say, an exam, a quiz, a problem set, something along those lines. So we really want you to become people who can take in data, process that data, and do something meaningful with it. And sometimes that means thinking about concepts conceptually. Physics is not just math. It is not just solving problems. It's also thinking about the concepts that are behind the problems. Math is a means to an end with physics. But also, in addition, it might also include actually doing some mathematical calculations, using some mathematical techniques that we'll briefly review in a little bit. So a metacognition strategy, or a strategy of thinking about how to learn and think, is to adopt what Carol Dweck, Professor Carol Dweck, a psychologist, calls a growth mindset. So this is in contrast to a fixed mindset, which is what people typically tend to adapt with science classes. A fixed mindset might just be, well, I can't do it. I'm just not good at math. Science is not for me, so it's impossible for me to ever do well in this course. And they've actually studied, and it shows that by having that mentality, you actually rise to meet those low expectations you've set for yourself, and that those sorts of students that have that sort of fixed mindset end up not doing super well in the class, because they are not acknowledging that the work that you have to put into any subject, or rather, it takes work to get good at any subject. I did not just wake up one day and was good at physics. I think sometimes we hear about like prodigies, like classical music, I feel has tons of these. Like Mozart wrote his first symphony when he was 5 years old. And if that's all you know, then it might think like, well, oh, I didn't write a symphony at 5, so why should I even bother to learn piano? But that's actually crap, right? Because what that doesn't tell you, actually, is that, one, symphony was not very good. A 5-year-old symphony was not good at all. We don't see that on, we are not seeing orchestras perform Mozart's first symphony, for example. It hides the fact that his father had already had Mozart practicing piano for hours a day at that point. Mozart did not, Mozart piano came a little bit easier to him, but that's not to say that Mozart woke up one day and was able to just suddenly compose and was, virtuoso at the piano. He was already practicing hours a day at the piano at that point. And so that is the sort of idea behind a growth mindset, where you're not acknowledging necessarily the end product, you're acknowledging the effort that has to go in for you to get that product. I know this is going to take some effort, and I acknowledge the work I've already done to get to this point. And maybe this isn't quite the point I need to be at yet to do well in this course, but I'm willing to make a plan and actually work towards doing better in this course. So what that means is, like a musical instrument, like other subjects, physics takes effort. Physics takes practice. There's a myriad of problems in your textbook. The textbook has all the answers to the odd number questions in the back of the book. You are strongly encouraged to try to do as many of those as you are capable of. Those are the sorts of questions that I might ask on an exam. They will help you prepare, and it will help you assess whether or not you are understanding these concepts that we are talking about in this course. And there's nothing to lose. You're not turning it in, so who cares if you get the answer wrong? But if you do get the answer wrong, try to figure out what went wrong and how you can learn from it. Don't just realize you got the wrong number and move on, but try to realize where you went wrong in your calculations or in your thinking that amounted to you arriving at the wrong answer. That is what's behind the idea of these kind of metacognition strategies. And again, for the in-person sections, we'll work a little bit of this in as well. The worksheets will have you kind of reflect on how you're thinking about these topics in groups, so that you can both learn from each other and try to get a better sense of how you are approaching these subjects and thinking about it. Because really, anyone can do physics. Physics is not restricted to only the privileged few. Physics is something that can be understood by everyone. And I hope that is something that we take away from this class, that at the end of the day, we are all capable of doing very well in this class. Yeah, this is kind of a strategy, which you'll see this kind of worked into the worksheets as well, where, in order to improve on a subject takes work, it takes feedback, it takes a willingness to try. With those three things, and kind of getting into this mindset of reevaluating your understanding as you go around and learn new things, you're able to come back and construct from your already solid knowledge even stronger aspects of how you learn and do physics. So, and again, we'll see this in the on-class worksheets. Kind of the idea is that you'll always have some sort of task at hand. Maybe it's a problem, maybe it's some sort of activity, maybe it's an experiment in physics 2. Or maybe it's just a general strategy of man, I really wish I was better at taking derivatives after learning them in calculus, for example. And the idea is that, you have this task at hand, and this actually kind of matches the scientific method in some ways too. And then the idea there is to evaluate your strengths and weaknesses, evaluate kind of how you are approaching the subject in the past, what you think about that approach is working and not working. If you notice that you're studying physics in a certain way, but your homework and your exams are not necessarily reflecting the score that you want to be getting, that suggests that maybe something you're doing to prepare could be improved upon. Then there's always the planning stage. How are we going to make a change? If you're changing your study habits, what are you going to do about your study habits that you're going to try differently? How are you going to access office hours more often? Are you going to work more in groups? Are you going to actually try to form a study group outside of class, for example? Are you going to use the STEM Center to get tutoring? Are you going to set some time aside to go over your lecture notes every day, for example? Those might be plans that you then want to implement and then apply and monitor how that changes your ability to perform in this class or in anything else that you're doing. This, again, is not unique to physics. This is something you could use in all your classes. And then the important, very important last step is to reflect. Based on your assessments, what are you seeing? Hopefully improvements. If you are seeing improvements, acknowledge the effort that you put into making those improvements. And then, essentially, the cycle starts over. Then that becomes your baseline, and now you can ask yourself, okay, now we're at this point. Good on me. Let's now work towards an even higher level of understanding. And this is not something I expect, to make sense overnight. This is the sort of thing where if you try to apply the strategy throughout the entire semester, the level of understanding and learning has been shown to be dramatically increased compared to just trying to memorize all the words and then hope that is enough for the exams.